Okay, science time. We're talking today about engineering problems. We're going to talk very briefly about engineering problems. This is mostly for the benefit of those of our fellows who aren't with us. If everyone were here, I probably was just going to say something like, let's go over the lesson self-check so we prepare for the quiz. But not everyone's here, so let's just talk real quick about the definitions of some of these things, what it is to have an engineering problem, and then we'll go over the lesson self-check. But I don't want to do it too much because I'm still going to check it tomorrow, so I don't want to give away answers as much as possible. What kind of problems can engineering solve? Any problem? What about the problem that some of these cowboys had at the wedding recently where they couldn't find a cute girl to dance with? Is that a problem solved by engineering? Probably. Okay, yeah, maybe build a snazzy rascal scooter and then drive up to her in it. That would be a good way to solve that.
Build that 250,000 car.
You know what? You're probably right. I mean, to some degree, you could say something like, you're an engineer and you make bank and you have a Ferrari. That's probably going to make it nicer to get some shotties. But I mean, is every problem solved by engineering? That was a borderline crass example, and I apologize for that. What's the meaning of life? Is that a problem solved by engineering? That question, no, it's not. To some extent, it may not even be a problem that society can solve, clearly. But there are certain problems that can be solved by engineering, and there are certain ones that can't. So what kind of problems can be solved by engineering? Just give me a few examples, and we'll kind of circle around the truth. Okay, coffee getting cold. I like that one, Lucas. Excellent example. Coffee getting cold. Okay, let's have two more. Not from Lucas. They don't have to be about coffee. In fact, I'd prefer if they weren't from now on.
My tea is getting
cold. Oh, good. Tea getting cold. Great job, Garrett. Water getting hot. All of the problems in the world are about the temperature of our beverages.
My ice cream getting warm.
Okay. Ice cream melting. We'll even go as far as to say that. All of these have to do with temperature control. What is the solution for problems of temperature control?
Turn freezers.
Yeah, there are various devices. What's a device these first two could probably be solved by something I have in this room. I'm using mine as a candle warmer, but there is a little like miniature hot plate over on my bookcase that I use as a candle warmer, but is actually intended to, like, you put your coffee cup on it and it keeps your coffee or tea warm. Water getting too hot? You could put it in the refrigerator. Has this existed for all of humanity? Yes. What if this was 500 BCE and your water was getting too hot? What would you do about it?
Put it underground.
Okay, yeah, so maybe there were still at that time ways to solve it, but they wouldn't be as efficient perhaps as the ones we have today. And furthermore, maybe today's methods of getting the water colder are less efficient than those that would exist in the future. We just don't know. But all of these can be solved by engineering. Ice cream melting, we have a freezer now. Are there other problems that aren't related to consumption of food and beverages and their temperatures that could be solved by engineering? Yeah, there certainly are. You can think of your own examples on your own time. Oh, someone really betrayed me with my whiteboard erasing. I really trusted them. At whatever group that was, I don't remember their group name. Would a good solution to the problem of my water that I'm trying to drink is getting too warm, would a good solution to that be put it on a satellite bound for Neptune and drop it into the atmosphere of Neptune? Is that a good solution? Why? For what reason? Would it make my water colder?
Yes.
So yeah, it nominally solved the problem. Why is that not a good solution? This is obviously an extreme example, but why? What am I getting at here?
It would be less efficient.
Okay, yeah, there are these things that we have in engineering called criteria. Oh no, this is even not writing good now. Criteria and constraints. The criteria are the goals. I hope someone's writing something down. Goals of the design. If one criteria of my design might be that it needs to make the water colder. Does my silly example just now, does that meet the brief? Does that satisfy the criteria? Yes, it does. But does it fit within the constraints? No. What are some implied constraints? Well, I want it to be on a small scale effective. I want it to be small scale. I don't want to have to spend $3.5 million or $6.7 billion to get my water cold. And I don't want to have it take up this room. And I don't want to have it take... There are also almost always engineering problems, time constraints. I don't want it to take the 13 years it takes to get from here to Neptune, plus the time it takes to design the vessel that will take it there. There are time constraints. I want it now. I want my water cold now. There are time constraints. What other constraints are there? There are cost constraints. Yeah, there are almost always cost. Let's actually, I like that better, Wes. Let's call it material constraints, which includes, in my mind at least, cost. Material constraints. I would really rather not spend any money on this if I want. The problem, my water is getting too warm, is not important enough to me to spend any money on it. I want it to be solved, but I don't want to spend money on it. Or at least I don't want to have some outlay of money. What I mean by that is that I don't mind if I go to the freezer and technically it costs the school more money because they ran the freezer for that 1 extra second, which technically gives them a narrower budget, which technically means that in the long run I get more money. That's not something I care about. But I don't want to outlay any funds. I don't want to spend a nickel to get my water colder. So there are material constraints. Are there design constraints? Yeah, like I can't I'm not trying to think of a way to phrase this that isn't going to make me sound stupid. I'm not smart enough to design something, some space age technology. I don't have the software required in my brain to design something that might be available in the future. And as a backwards example, if I'm an ancient Mesopotamian in 2500 BCE, I don't have the software required to even think about refrigerators in general, so that wouldn't work. Right? I can't tell the future. I can't know what future technologies are going to exist, so there are design constraints. There are other kinds of constraints, and there certainly can be more specific constraints. For instance, instead of just having material constraints on a project, we might say we can only spend 13 bucks. The constraints can be more specific than these, but these are some broad categories of constraints. And then, of course, the criteria should be more specific than just goals. You should actually have goals. And you know this from your lab. Did your lab have a criterion? What was it? What was the criterion of your lab, Garrett? Yours.
Oh, I don't know my lab.
What? Holmgren? Goodness gracious. Lucas, what was the criterion of your lab? You do know what it was, Lucas, just tell me.
To make a reflector.
Yeah, okay. A mirror is what we call reflector things sometimes. The criterion was make a mirror, design a mirror. What were the constraints? Well, you couldn't spend 3 weeks on it. You couldn't spend $180 on it, right? That you had material and time constraints. We also had design constraints. You were limited on how well you could design a mirror. You don't know how mirrors are made. I'm not being mean, Lucas. I'm just being frank. You don't know how mirrors are made in real life. Like a real mirror you would buy at Walmart or mirrors.com or whatever. You don't know how that's made, and so you had some design constraints. You were unable to design a perfect mirror because of the design constraints. But you also had, even if you were able to do that, even if you had done a whole lot of research, which was one of the topics of your explorations, even if you had done a whole lot of research to look into how to design a mirror, and you did find out, oh, this is on how it's made, how they... You would still have material and time and scales constraints because we don't have the same techniques and materials available that the people that actually design mirrors have. Does this all make sense? Okay, let's move on. I'm just going to talk about some of the stuff on Listen Self-Check real quick. You should be able to identify some problems in society that could be solved by engineering. You should be able to list the criteria for those, and you should be able to list some constraints for those. I would say that would be pretty satisfactory for the quiz. Do you have questions about any of this? Okay, let's call that good then. Bye. Uh-oh, did I forget to...